Hello everybody and welcome back. Here's a quick video about inequalities, what they are, what they look like, and how to solve some basic equations that involve inequalities as well. And we'll even throw in just a little bit of graphing. Let's get started. Okay, first things first, here are our general inequality symbols. From left to right, we have less than, greater than, less than or equal to, and greater than or equal to. There's also some key phrases that I would recommend you have in your notes for reference later on. For example, the first symbol up here, which is less than, we can also describe using phrases like is fewer than. That's a common one that we'll see. Next, we have greater than, of course, which we could also represent by saying is more than. The next two are going to be especially important because there's quite a few phrases that show up that can be a little misleading. What I mean is, for example, next we have less than or equal to. Sometimes that same symbol can be represented by saying phrases like is at most or is no more than. Finally, we have greater than or equal to, which could also be described using phrases like is at least or is no less than. Now, again, I recommend you write these down for later access, again, because they can be confusing or sometimes feel a little bit misleading if you're not careful. And I'll give you one quick example why. On this last symbol, which is greater than or equal to, of course, we understand greater than being something larger than, but then there's a phrase like is at least. And unfortunately, sometimes when we see words like least, we think of things being smaller, but the phrase at least means equal to or bigger than. For example, if I need at least $20 to go to the movies, I know that I would need $20 or more. So please have access to these later on. Next, we'll do a quick reminder of how graphing works with inequalities, which you will also use when you solve a variety of inequalities. So we've got different things here. The first one is x is less than 5. So when graphing inequalities, you have to consider two things. One, what kind of point should you use, those options being open or closed? And then second of all, which direction should your arrow highlight on the graph to identify which kinds of solutions would make this statement true? So if I started with x is less than 5, first thing for you guys to remember is that less than or equal to actually use what we call an open circle or an open point. So right here on the 5, I'm going to draw an open circle. Again, open meaning that it's simply not colored or shaded in. Next, I need to identify which part of the number line do I need to highlight to graph all of the solutions that could make this true. Well, if x represents numbers less than 5, then my arrow would need to go to the left. Any number that is then highlighted or has been colored over at that point then would make this inequality true. For example, what I mean is I see 4 is underneath the line I just drew, and 4 is less than 5. That makes that true. Or we could choose answers like 3, which is less than 5, or 2, or 1, or 0, or anything else to the left of that number would make that statement true. And that's a great way for you to double check if your graph has been drawn correctly. Next, we have x is greater than or equal to 9. So when we have the greater than or equal to or less than or equal to symbols, that's the time when you actually use a closed circle, meaning we know we need to put our point or circle above 9, but this time it's actually going to be fully shaded in. That shaded in circle then indicates that 9 can be included as a solution. This time my answer should also represent things not only equal to, but greater than 9, so I am going to draw my arrow to the right to highlight all the possibilities that would be greater than 9. But this time when I go to check my solutions, remember that 9 is included. It is an option here. So I want to make sure, is 9 greater than or equal to 9? Yes, it does fit one of those conditions. 9 is equal to 9, so it works. And then, of course, we could also substitute in values, such as 10, which is under my line, or 11, 12, 13 and a half, 15.7, anything else greater than that point also makes this statement true. So again, when you are graphing inequalities, make sure you pay attention to whether you have an open or a closed point, and then also what direction are you going to highlight on your graph. The last thing that we'll review is how to solve inequalities here. So we'll use a very basic one to start. And the good news is that solving inequalities is nearly identical to solving equations, meaning we'll still use inverse operations. And we'll still use skills like SADMAP, or in other words, the order of operations in reverse if it is a multi-step inequality. Right here, I see that I only have one operation, which is addition, and so we'll go ahead and use the inverse of addition to isolate the variable. So it says x plus 7, the inverse would be to subtract 7 from both sides and simplify each expression. Of course, on the left here, 7 minus 7 is 0, so these effectively cancel each other out, and I am just left with x. So my variable has been isolated. And then we have negative 2 minus 7 more, which leaves us with negative 9. So x is going to be less than negative 9. Notice in this situation, the inequality symbol carries straight down. Now you may be asked to also graph that inequality just to make sure we are actually processing what our answers mean. And if you had to do it by hand, I would sketch a quick number line, making sure I have arrows on both sides. Generally speaking, I like to put my starting point of my solution right in the middle. Just gives me a nice reference point. And then just a few points on either side of that will help model enough for us to see what's going on. So I'll go ahead and label a few of these points. And then I can consider what we talked about a moment ago, which is first, what kind of point do I need to use? Well, I see that my symbol is just a less than symbol, meaning I get to use an open circle. So there we go. And then I know that all of the values that should make that statement true should be anything less than negative 9. So I'm going to highlight all of these numbers here that are less than negative 9. And what that means is that if I were to choose any of these numbers, for example, negative 10, I should be able to put that value back into my original inequality, and it should still make it true. Now, this is the difference between equations, because when we solve an equation, you typically have one value that makes it true. And here, you could have technically an infinite amount of solutions that would make it true. Let's go ahead and test this out so you understand what I mean. If I were to choose, for example, negative 10 in place of x, I would say, what is negative 10 plus 7? And really, I'm asking, is it's still less than negative 2? Well, negative 10 plus 7 is actually negative 3, and negative 3 is in fact less than negative 2, which means that yes, negative 10 could be a solution that would make this inequality true. So that's a nice simple inequality to start solving, but we'll look at one more option. So in this final example, we see the inequality negative 2x plus 5 is greater than or equal to 9. So it is going to be a multi-step inequality that we would need to solve through. So we can still use that same SADMAP, or what I call SADMAP process, which is just, of course, PEMDAS in reverse, or the order of operations backwards, which means we'll start looking for any addition or subtraction first, which of course we have. We see a plus 5. The inverse would be minus 5, or subtracting 5. And we'll simplify each expression. 5 minus 5 is, of course, 0, but we are left with a negative 2x this time. And a 9 minus 5, of course, leaves us with 4. So negative 2x should be greater than or equal to 4, but we still haven't isolated our variable. That next step, of course, would be division or multiplication, and we do have some multiplication. So the inverse would be to divide by that same coefficient. We divide by negative 2 on both sides of the inequality, and just simplify. Negative 2 divided by negative 2 is, of course, positive 1, or in this case, 1x, which is great because we were trying to isolate the variable the whole time. And then 4 divided by negative 2 would be negative 2. So it appears at this moment that x is going to be greater than or equal to negative 2. We're going to graph that quickly so that we can make sure that we made sense of everything. And so I'll sketch just a real quick number line, putting my starting point right in the middle, negative 2. Of course, some things greater than would be negative 1, 0, and 1. Just a couple over there on the left. Negative 1, 0, and 1. And based on what we have right now, we know that we're going to go ahead and need a closed circle this time because our symbol is, greater than or equal to, so we have to shade in that circle. And then we would highlight anything greater than negative 2. Okay, so we've got a lot of numbers that are greater than negative 2, like negative 1, 0, and 1. I'm going to try and make my life a little bit easier by choosing one of these solutions that would make the calculations quick and easy. I'm going to choose 0. In this case, I'll go ahead and substitute 0 into my original inequality and say, what is negative 2 times 0 plus 5? And if we've done everything correctly, then we should be all done. Well, negative 2 plus 0 is, well, 0. In essence, this part is gone, and we're just left with plus 5, or in this case, positive 5. So I'm basically left with this part of the inequality, which I'll rewrite over here on the left, which says that 5 is greater than or equal to 9. Wait a minute. 5 isn't greater than or equal to 9. What happened? Did we do all of our steps correctly? Well, we subtracted 5, which is the inverse of adding 5, so that's okay. We divided by -2, which is the inverse of multiplying by -2, so that's okay. So it seems like all of our arithmetic is correct, so what else did we miss? Well, this is actually the reason I brought this example up, and it is because of this last step that something special had to happen. And this is a great thing for you to write down into your notes so that you'd have access to it later on as well. Anytime you are solving an inequality, if in the problem solving process you end up multiplying or dividing by a negative, which is what we did here, we had to make that step happen. That's part of the algebraic process that we had to do. When that step has to happen, if it involves a negative, then the inequality gets reversed. Here's what I mean. If it was a less than sign, it will become a greater than sign. If it was a greater than sign, it becomes a less than, and so on and so forth, which means that our original symbol, which was greater than or less, I'm sorry, greater than or equal to, that should have actually been reversed at this step, meaning, if I can get this to erase, there we go, meaning that we should have ended up with a less than or equal to symbol instead. Okay, so one more time, if you have to multiply or divide by a negative, you have to reverse the inequality, which means really we should have reversed our graph as well. It'd still be a closed circle, that hasn't changed, but we definitely should have highlighted the other side of the graph, meaning we'd have any numbers that are less than or equal to -2. So hopefully that's a good review for you guys. If you have any questions, as always, please feel free to let me know, and good luck.